So here is problem 8 on the first homework, and your local power company has charged you $56.83 at a rate of $0.0264 per watt for a month's use of electricity. How many watts of electricity did you use? So let's start with our usual way of looking at these problems. Let's first write, what are we given? And what do we want over here? And what we want to know is the answer in watts. How many watts of power? And what we are told is that it is, at a rate of, I'm going to do this in dollars, so 264, and that is dollars per watt, and we spend a total of $56.83. Now we need to cancel those out to give us our answer in watts. So watts is on the bottom in this, so that has to be inverted. That's start on top. So it's going to be 1 watt for every $0.0264. And now I can simply multiply that by the amount of dollars I spent, $56.83. Those units cancel, and I'll be left with watts. So when I simply do that division problem, 5683 divided by 0.0264, I can get to my answer. And that is question 8. The key here, what you want has to go on top. So here is question 9 from the first grade homework. And it is going to be another unit problem. So we have this rectangular pool. And that just simply means there's a, I don't know, we'll call that a length. So a length, a width, and a height. And to get the volume is length times the width times the height. And we have to keep our units good. So in this case, it is going to be 5.3 meters times 3.6 meters times 2.5 meters. And we'll do the math, but the units turn out to have to be in cubic meters. But what we want here are milliliters. So what we are given in this case is a volume in cubic meters, which remember, that's equal to meters times meters times meters. Nothing hard there. And what we want to end up with in milliliters. And when we go between these linear measurements that are made to make a volume and the SI system, we're going to go through this pathway that is using the equivalence between 1 cubic centimeter equals 1 milliliter. So we've got to go from cubic meters to cubic centimeters, which remember, that's just simply centimeters times centimeters times centimeters, and then we can go to milliliters. So our process will be whatever that turns out to be. I'm going to go ahead and do that calculation. Okay, so when I do that multiplication together, what this turns out to be is 47.7, but this is in 2 significant digits, so is everything else, so we have to do this in 2 significant digits. That's 48 cubic meters, which is equal to 48 meters times meters times meters. Now what I have to do is get rid of meters, and I want to make that centimeters. And I know that there are 100 centimeters for every 1 meter. But remember, there's cube. We have to get to the 3 of them. So I can do that 3 times. So 100 centimeters per 1 meter times 100 centimeters for every 1 meter. And then I cancel those units, meters, 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 meters. Or I could have just cubed those, either way. And then I have now centimeters times centimeters times centimeters, that's cubic centimeters, and then my last step is to get rid of cubic centimeters, right? So that's 1 cubic centimeter for every 1 milliliter, and that will get me to my answer. But this is just remembering that when we go from linear measurements to some kind of formula to make a volume, we have to cancel every one of those units. We can't just cancel meter, make it a centimeter. It has to be meters times meters times meters, and you usually do that by just cubing both the number and the unit. Okay, that is question 9.